Hello dear all, welcome to the another video of our course, that is Discrete Mathematics. So today in this video we are going to study the basic of set theory. So without wasting much of time, let's start our discussion. So set is nothing but a collection of objects, and the objects that comprise of the sets are called elements. So set is nothing but a collection of the objects, and these objects are known as elements. For example, we can represent the sets of chairs, and we can also represent the noble literature in form of sets. We can also represent the integer in the form of sets, and we can also represent the set of natural number which is less than 10. So usually, set is nothing but the collections of objects, and usually represented by it list of elements separated by comma between two curly bracket. For example, we can represent the list of integer bigger than 0 and lesser than 5 or equal to 5 using this set. So we can represent this set using the list of element separated by comma between two curly brackets. So this is how we can represent this set. So we can represent this set using these curly braces, and inside these curly braces we need to write the element of that particular set. Here we have a set of integer that is bigger than 0 and less than or equal to 5. So we can represent this set like this. So this 1 2 3 4 5 is the element of the sets, and the elements of the set need to separate using comma, and every element of a set need to represent inside these curly braces. So this is how we can represent a set. So another example of a set is set of odd number, and we can represent this set using these curly braces, and inside these curly braces we need to write the element of this set. Here this set is the set of odd numbers. So we have 1 3 5 7 9 11 up to infinity. So this is the set of odd numbers. So another example of set is the list of vowels in English alphabet. So we can represent this set using these curly braces, and inside these curly braces we need to put all the vowels in English alphabet. So we have A, E, I, O, U. So these are the elements of these sets, and every element of these of a set need to be separated using comma. So this is how we can represent set. So usually a set is represented by its list of elements. So these are the list of element and separated by comma between two curly braces. So this is how we can represent set. And the number of elements in a set is called the cardinality of a set. So the number of element in a set is known as the cardinality of a set, and the cardinality of set is denoted using this symbol. If S is the set, then the cardinality of a set S is represented using this symbol. So cardinality is the number of element present in a set. For example, we have let A is the set of integer bigger than 0 and lesser than or equal to 6. So we have a set called A, and inside this set we have an element that is bigger than 0 and lesser than or equal to 6. So we have 1 2 3 4 5 6. So this is the set according to this definition. So we have how many numbers of element are there in this set A? We have 1 2 3 4 5 6. So the total number of element present in this set A is 6. So the cardinality of A is represented using these symbols, and the total number of element present in this set is 6. So the cardinality of a set is the number of element in a set. So the number of elements, so here in A we have 1 2 3 4 5 6, so 6 number of element, then the cardinality of this set A is equals to 6. So similarly, let S is the set of vowels in English alphabet. So we have a set as, and the list of vowels is A, E, I, O, U. So the cardinality of this set as is 1, 2, 3, 4, 5. So total number of element in this set S is equals to 5. So the cardinality of this set as is equals to 5. So the cardinality is nothing but a number of elements, but number of elements present in a set. So in this set, as we have 5 number of elements, and we can represent the cardinality using this symbol. So this is how we can find the cardinality or number of elements in a set. So suppose let Z plus is the set of positive integer. So set of positive integer, and what will be the cardinality of Z plus? So Z is here, Z plus is the set of positive integer, and we need to find the cardinality of Z plus. So it is possible to find the cardinality of Z plus. Here the Z plus is the set of positive integer. So the positive integer is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 up to infinity. So it is not possible to list out all the element present in this set, that is Z plus, which is the set of positive integer. So the cardinality of this Z plus is infinity. So we don't know how many elements are there in this set. Here Z plus is the set of positive integers, and we don't know how many positive integers are there. So we don't know the actual number of elements in this set. So the cardinality of this set is infinity. Therefore, the number of objects in a set can be finite or infinite. So finite means fixed number of elements are theirs, and infinite means we don't know how many elements are there in a set. So if we don't know how many elements are there in a set, then this type of set is known as infinite sets. And if we know the number of elements, if you know the numbers of elements in a set, then this type of set is known as finite sets. So here we are going to see some examples of finite as well as infinite set. So first, number of students in a school, it is finite. We know, or we can count the number of students in a school, it is finite. And another example of finite set is number of fish in Indian oceans. We don't know how many fish are there in the Indian Ocean, but still it is finite. And another example of finite set is number of human in this world. It is also a finite, though it was changing day by day, but still it is finite set. So number of all prime number is infinite. So this is the example of infinite set. So prime number means 0, 2, 5. These are the prime numbers which can be divided by 1 and itself. So this, we don't know how many prime numbers are there in this wall. So this is infinite. So another example of infinite set is list of odd number. So list of odd number is also infinite. And number of stars in universe, it is infinite. It is infinite as well as uncountable. Further, the infinite set is divided into two categories, that is countable and uncountable. So set of integer is still countable, but this set of star in a universe is infinite as well as uncountable. So those infinite set which can be count using the natural number, then this type of set are countable infinite sets, and those sets which are uncountable in nature and uncountable, this type of sets are called uncountable sets. So example of uncountable sets are sets of star in universe, and set of real number is also uncountable. So these are the some examples of finite sets and infinite sets. Now we are going to learn about the empty set. Any set that does not contain any element is called empty set or null set or void set. And this symbol used to represent this empty set is this curly braces or using this symbol called phi. So we can represent the empty set using these two symbols. So the empty curly braces and this phi symbol. So any set that does not contain any element is called empty set, and these symbols, these curly braces, empty curly braces or phi is used to represent the empty set. So and the cardinality of empty set is 0. So in a empty set we don't have any element. So the cardinality, by default, the cardinality of empty set. So this is the symbol to represent the empty set, and the cardinality of empty set is 0. So this is the how we can represent the empty set, and this is the cardinality of empty sets. Now set is nothing but a collections of elements where the ordering of elements in a set doesn't matter and no element is repeated. Which means if we have set like this 3, 1, 2, 2, 4, 4, which means this set is the actually is equal to this set, because in a set we doesn't allow the repetition. So if we have the repetition in a set, then we need to take it as one element. So in general, this set is the collections of element where repetition is doesn't allow. But in some case we may have to allow repetition. Such set is called multi-set. In those sets repetition is allowed, then this type of set is known as multi-sets. And thus in the multi-sets 1 1 2 is different from 1 2. But in general, in general case 1 and 1 2 is equals to 1 2, but in multi-set the repetition is allowed, therefore this set is different from this set, and this set is different from this set. In some contexts we may have to allow repetition. Such set is called multisets, and this multiset is different from this multiset, and this multiset is different from this multiset. But if we are talking about the normal set, then this and these sets are equal, and these sets are equal, because in normal set the repetition is not allowed, but in multi-set the repetition is allowed. Though the repetition is allowed, therefore this set is different from this set, and this is different from these sets. So that's all for today's lecture. In our upcoming lecture we are going to see the different types of operations of a set we can perform on a sets, and we are going to see how to represent the set using set builder notation. So that's all for today. See you in next video.